When you're working with a model that's calibrated to data, oftentimes you've got a lot of questions about the uncertainty of your calibration. As many of you know, you can find multiple ways to calibrate a model that look identical in the past, but have very different values in the future. So something we've always wanted to do is quantify that uncertainty. What are the outputs that I could reasonably expect in the future based upon all of the possible calibrations of the model, which could be considered to be valid? So we can see in this case, I've got calibration temperature for surface temperature anomaly, and my baseline run in red. And if I look at GDP, I can see it like this. So to do that, we've added some features to Stella that allow you to terminate runs in a sensitivity analysis based upon the value of a payoff. So what I can do here is I can run my model once and go to Window, Open Message Log Panel, and it'll show me that the full payoff, which is the payoff that I've computed for this model across all data that I have, yields a value of 2,532.98. Okay? So when I go to the sensitivity analysis, I can set up criteria here, and I can say terminate any run whose full payoff value is above 3,500, aka any run which doesn't fit reasonably well in the past, throw it away. Don't count it in my sensitivity analysis. Keep only the runs whose payoff value is reasonable as computed. Hit OK. And you see here that I'm doing 1,000 runs of Sobel sequence sampling. And these parameters that I'm testing across are the uncertainty and climate feedback. Climate feedback from surface temperature anomaly, more or less back to economy and population. And so if we switch to the confidence interval charts and we do a run here, you can see here that as the sensitivity analysis runs, that it's filling in, but it's not keeping every single run that's being run in the sensitivity analysis. Some of those runs are falling out of bounds. They don't fit history well enough to be included in the set. But as you can see, many of the runs do fit history well enough to be included in the set. And now we can see the uncertainty in surface temperature anomaly based on the climate feedback uncertainty. And we can see a much larger uncertainty in GDP based upon the climate feedback uncertainty.